So at this point in our careers with series, we only know two types of series for which we can find a limit: telescoping series and geometric series. Otherwise, we don't know the limit of the sum. The claim is that my claim is that this is a telescoping series, but I got to do the partial fractions to figure out how it telescopes, which means breaking this into a sum or a difference. So I need to take that 3 over k times k plus 4 and rewrite it as something over k plus something over k plus 4. And our procedure for that is we multiply each side by the denominator, k times k plus 4. And when we distribute that through, we get a bunch of cancellation. And we end up with, on the left side, a 3. On the right side, we're going to get an a times k plus 4 plus b times k. And when we did this back in integral calculus, we picked clever values of k to figure out what a and b were. And so the first clever value for k I have is 0, because if I make k 0, then the bk term vanishes, and I get 3 equals a times 4. Solving for a, divide by 4, I get a is 3/4. If I let k equal -4, then the first term is going to vanish, and I get 3 equals b times -4. Dividing by -4, I get b equals -3/4. So that's important because in my sum up here, I have a 3 over k times k plus 4 with that -1 to the k plus 1, my alternating part. So based on this right here, I can rewrite the original series to be the sum as k equals 1 to infinity of -1 to the k plus 1 times 3/4 over k minus 3/4 over k plus 4. So this is my new sum. Another way I can do it. Now, I just want to write out this sum in two different ways. So I'm going to do the first version of it in blue, write out some of the values. So at first, if k is equal to 1, I'm going to get a -1 squared, which is positive. So I'm going to have 3 over 1 times 1 plus 4 would be 5. The next term, k is 2. 2 plus 1 is 3. I'm going to get a -1 cubed. That's going to be a minus. So it's going to be strictly alternating. 3 over 2 times 6. And then I'm going to get a plus 3 over 3 times 7. And then a minus 3 over 4 times 8, and so on. And we could plug this into Desmos and get some partial sums, but I just want to look at it to start with. Always a good idea. The other version, based on the green, says this ought to be equal to, if k is 1, I'm going to get a -1 squared. So I'm just going to have a positive parentheses. 3/4 is hanging out on top over 1 minus the 3/4 over 1 plus 4 is 5. And k is 2, I'm going to get a minus 3/4, and I guess it would have been nice to factor that 3/4 out. Oh well. 2 minus 3/4 over 2 plus 4 would be 6. And here I'm going to list a few more because I want to illustrate what's going to happen in terms of what the telescope means. 3/4 over 3. Oops. Minus 3/4 over 7. Do 2 more. Minus 3/4 over 4. Minus 3/4 over 8. And then the next one will be 3/4 over 5 minus 3/4 over 9. And this is just going to keep on going. Dot, dot, dot. Notice denominator of 1, 5, then 2, 6, then 3, 7. The 5 in the denominator is being subtracted. And eventually the first part of each of these parentheses will catch up. And now I have a 5 here, and those two will cancel. So from this point onward, each of the first terms here, first parts of these, is going to cancel based on this one over here. So the next one after this is going to have a 3/4/6, which is going to cancel with this guy. So forever after, so this is the whole telescoping part. Although this sequence appears to be going out to infinity, after, in this case, the fifth term, it collapses on itself. And it cancels forever on. What does not get canceled? Well, this got canceled, and this got canceled, and this got canceled, and this got canceled. And those are being canceled starting here with this first term, and then it keeps going. What's not canceled then is this, and this, and this, and this. Everything else is gone. So what must this blue sequence of numbers converge to? It must converge to, I'm going to pull the 3/4 out this time, and then I'm going to have a 1 minus a half plus a third minus a fourth, and that's it. That's all that's left of the green telescoping version of this series. So let's test that out in a calculator to see if this is indeed the converging sum for this infinite series right here. Again, my point earlier was there, at this point in our lives, we only have two ways to find the value of convergence if a series converges: geometric or telescoping. Let's get Desmos out. Oops, I could spell Desmos. So first I'm going to enter what I think the convergent value is. It's a 3/4 times parentheses 1 minus 1/2 plus 1/3 minus 1/4. And then after that, everything goes away. I believe that's the sum. I'm going to call S of x. So I'm going to write this as a function. Sum as n goes from 1 to x of -1 raised to the power n plus 1 times 3 divided by n times parentheses n plus 4. So that's the series I was given with n's instead of k's. And I'm going to find the 10th partial sum and the 100th partial sum, because the computer can do them so fast, and the 1000th partial sum. So the original version of the series is not collapsed. We have to rewrite it to be a difference of two terms that catch up to each other. In that case, we do get the collapse. The collapse value, which should be the limit of this infinite sum, is 0.4375. And notice by the 1000th term, I can see I'm getting pretty close to 0.437 and starting to approach that fifth and 10,000th spot. So again, telescoping series at this point is one of the few series for which we can actually say, not only does it converge, but it converges to this number. What number? That one right there. 4,375 10,000ths. Note, if these two factors in the bottom were, these are 4 apart, and notice the telescope didn't collapse until after the 4th term. If they were 5 apart, it wouldn't collapse till after the 5th term. If they were 10 apart, it wouldn't collapse till after the 10th term. So if you want to know what the sum is, you got to look at the first 10 parts of the telescoping version. And the first term of each of those are what remains. Everything else disappears in the limit. Beautiful, wild, and true. I love series.